Okay, so let's take a look at another question. This comes from the 2023 HSC Advanced Maths paper. HSC Advanced Maths. This is question 28. So we're told the curve y equals f of x is shown in the diagram. The equation of the tangent to the curve at the point t16 is y equals x plus 7. At the point R, another tangent parallel to the tangent at t is drawn. The gradient function of the curve is given by that formula. Find the coordinates of R. Okay, so 4 marks, quite a big question. Immediately, we have been told the slope of the line at R and the slope of the line at T. We have also been told that this is a tangent to the function. So this means the derivative of the function at the point R has a value equal to the slope of the line y equals x plus 7. So y equals x plus 7, this is the tangent line up the top. It has a slope of 1. M is equal to 1, y equals mx plus b. This means the slope of the lower tangent that passes through R is also 1. So the m slope passing through R is 1. But this is the value of the derivative at the point R, because the derivative gives you the slope of the tangent. So this implies that 1 is equal to dy dx, and this implies that 1 is equal to 3x squared minus 6x minus 8. We know this because we've been told that this is in fact the gradient function. So now all we need to do is we need to solve this. So now we're just going to solve. So we have minus 1 from both sides. We've got 0 is 3x squared minus 6x minus 9. Divide everything by 3. This gives us 0 is x squared minus 2x minus 3. Now we need to either factorize this or use quadratic formula. So we need two numbers that multiply to give minus 3, add to give minus 2. That could be minus 3 and plus 1. So this becomes x minus 3 and x plus 1. So this implies the solutions are x is 3 and x is minus 1. Now of these two values, x is minus 1 is actually point t. And you can see this because it tells you that the equation of the tangent to the curve at point minus 1, 6 is y equals x plus 7. Well, we've just solved where this curve has tangent slope of 1, and it's shown us that this is true at minus 1 and at 3. Well, t is the one where it's minus 1. And this means that r is the one where the x value is 3. So now what we need to do is we need to find the y coordinate of r. So we've got the x coordinate of r. X coord of r is x equals 3. And now we need the y coordinate. We could do this a few different ways. We could try doing this with the lines. So we know the slope of both of these lines. We know the slope of the top line. We don't know how far the top line is from the bottom line though. So that method is going to be a little bit tricky. What we could do is we could integrate the gradient function to get an equation for the function. We could find the constant of integration using the fact that we know this passes through the point minus 1, 6. Then we could plug x equals 3 into that function. Right? So that will give us the y coordinate as well. So that's what I'm going to do. So I'm going to say use the integral of 3x squared minus 6x minus 8 dx. This is going to essentially be equal to the function. So the integral of 3x squared, this will be x cubed, or the antiderivative of 3x squared is x cubed. And then we have minus 3x squared, and then we have minus 8x, and then we have plus a constant of integration. Now to find this constant of integration, we're going to use the fact that we know the curve passes through the point minus 1, 6. Minus 1, 6 is a known point on this curve. This will help us find this constant. So this implies that 6 is equal to minus 1 cubed minus 3 times minus 1 squared minus 8 times minus 1 plus a constant. We get 6 is minus 1 minus 3 plus 8 plus c. Well, if we minus 8 from both sides, this gives us minus 2 over here. If we add 4 to both sides, this gives us c is equal to 2. So we've now found an equation for the function. So this implies that the function of x, this curve, actually is x cubed minus 3x squared minus 8x. And then we need to be very careful with the sign here. It looks like it's going to be plus 2. Let me just confirm that this number is right. So we have x cubed, we have an 8, we minus 8 from both sides, this gives us minus 2, we add 4 to both sides, we get minus 2. So it is going to be plus 2 from my working here. And now, and you've got to remember, this diagram does say not to scale, right? They've made it incredibly clear that this is not to scale. And so this looks wrong because the y-intercept looks to be negative, but we've just found a positive, but it's not to scale, right? So you can't actually tell if that's meaningful or not. So now we need to let x equal 3. We're going to get f of 3, which is the y-coordinate we're after. The y-coordinate of r is 3 cubed minus 3 times 3 squared minus 8 times 3 plus 2. So this is 3 cubed minus 3 cubed. These just cancel. We have minus 8 times 3 is minus 24. Minus 24 plus 2 is minus 22. So therefore, r is at 3 minus 22. This is the coordinate points for r. Now let's go through the marking for this kind of question. This is worth a lot of marks, and so the marks are, in a sense, rewarded in a sort of progressive fashion. So if you are able to use the information you have given to start solving the question, this will get you 1 mark. So doing something with an integral or doing something with the gradients or something like that, that's going to be the first mark. You will have to find an x coordinate. You'll have to find one of the coordinates pretty much in order to get a second mark. So if you've done some work and you've got one of the coordinates, or if you've done something with the gradients and then you've done something involving integrations, this may also get you the 2 marks. The third mark is really going to be something along the lines of finding a coordinate or doing all of the setup. So in the way that I've done this, they would essentially expect that you've got the c for the cubic, you've evaluated the cubic, you found the x coordinate, you found everything except the y value in order to get 3, and then for the fourth mark, you're going to just have the point, right? So you're going to need the x value, the y value, all of the working associated with that, and that's going to get you 4 marks. And this type of question can be done in a sort of few different ways. You can sort of do the things in different stages. The markers will be very lenient towards this. The markers are not going to judge you overly harshly because you took an integral before you dealt with the slopes, right? It doesn't really matter the order in which you're doing these, and the marking will reflect that.